Okay, hi everybody. Looks like we've got a few more still coming in, but so my colleague James in the background will be admitting people and also answering questions in the chat if you have any. My name's Ellis. I head up the specification and business development team at Recoup. So the presentation today is essentially wastewater heat recovery for residential new build, covering elements of the new Part L and how wastewater heat recovery integrates with that. This is a residential biased presentation. We do have presentations for non-residential, so if you are a specifier architect looking at non-residential projects, please do give us a shout. We have case studies and things, or if you want to stay on at the end, I do have some case studies.
Sorry, I missed the last 2 minutes of what you said there. I lost something, I think signal wise or something like that. Can you repeat what you said there?
Sorry, yes. So I'm Ellis. I head up the specification team at Recoup. This is a residential new build.
You went to the cafe with John and you've just basically said bye to him right now. I got up to there.
I think we might be at odds here. Just because we've got a lot of people on the presentation, would it be okay if we could just mute for the moment, and then if there's any questions, maybe pop them into chat? Thanks. Okay, right, let's move forwards then. So as I said, we're going to break this down into a quick overview of wastewater heat recovery and how it works, some information on product detail on the products in the portfolio. Why is wastewater heat recovery important? Why is hot water an important component for future homes and Part L 2021? A brief overview on designing in and the impact of wastewater heat recovery for Part L 21, and then some case studies and hopefully time for some Q&A at the end. At the end of each of these chapters, I do have a pause for some questions. So we'll just pause, see if there are any questions from the floor on those elements. Hopefully you won't have missed anything. But as I said, James is in on the chat. So if you do have questions, please do feel free to put them into the chat as well. Okay, so who uses wastewater heat recovery? Well, in the UK at the moment, the main use is from house builders and developers who are looking to use wastewater heat recovery essentially as part of a suite of measures to achieve Part L compliance. As I'm sure most of you know, we have an update on the Part L regulations, which we're currently in the transition period for. So the last change was in 2012. But this new Part L regulations, Part L 2021, come into force last year and has a 1-year transition period, which will we will transition fully from June 2023. So the clock really is ticking. We're 4 months away now until all new build homes in England will need to meet Part L regulations. So we're seeing a lot of interest for wastewater heat recovery because of that reason. But as well as new build houses, we also have products that are suitable for apartments, for bungalows, essentially anywhere where there are showers. So as well as residential, we're also seeing a big amount of interest for hotels and student accommodation projects, especially new build projects, but also retrofit. Obviously sports and leisure facilities where generally you have high shower traffic use environments. So again, anywhere where there's showers and especially high shower traffic, wastewater heat recovery can really make big impact there. But looking forwards, we're also expecting a big uplift in interest from housing stock upgrades and domestic retrofit. In the UK, the driver for retrofit tends to be eco, which is the funded driver for retrofitting homes. That currently focuses mainly on space heating measures, but the expectation is the legislation will change, if not this year, then early next year, to allow hot water heating measures to be included. So wastewater heat recovery really is the low-hanging fruit there. So we will be putting together another CPD based on both non-residential and Part L and also domestic retrofit going forward. So if you have interest on that or if you have projects, please do give us a shout.
Hello, can you hear me?
I can just about, yes.
There's a terrible echo. I'm getting a terrible echo.
Apologies. Okay, let's see if I can move my mic. How is that for everybody? James, am I coming through okay?
That's better.
Okay, thank you. Sorry about that. Okay,
Yeah,
so
it all seems to be going through okay now. So
thanks, James. So why use wastewater heat recovery? Well, it is a heat exchanger technology which essentially reduces the hot water or heat energy demand for showering, and it can reduce energy quite significantly and also obviously consequent CO2 emissions. So for new build, where Part L regulation is a requirement, it can offer a cost-effective energy efficiency solution to achieve SAP points to help achieve Part L, but also it's very easy to design into existing homes. So it really is a winner for new builds particularly, and certainly new build housing. As I said, simple, cost-effective Part L compliance. Nobody really wants to think of their product as a box ticker, but it does tick the box for SAP very, very well in terms of high SAP points, high efficiency, and low installed costs. So it really does tick the box very well there. But from an impact point of view, it can offer significant hot water cost reduction. So for the main product, which we'll sort of focus on in a moment, designed into a new build home, the expectation would be around about 55% reduction in energy and or hot water requirements per shower use. So it really is quite significant there. And quite importantly, there's no end user interaction required. So unlike a lot of other technologies, it can't be switched off, it can't be removed. It will always work every time a shower's switched on. So for all intents and purposes, it's part of the plumbing infrastructure and doesn't need to be switched on or switched off, or in fact can't be switched on or switched off by end users. So it really is quite useful in that respect. It's very easy to design in, sorry that's greyed out there, but we'll look at that as we go through. Essentially it is a fit and forget technology, so it's completely passive. It has no mechanical, moving or electrical parts, no filters or consumables, so it will just work, as I said, with each time the shower's switched on. And it has a long working lifespan, so certainly BEIs have attributed up to between a 40 and 60 year working lifespan for wastewater heat recovery vertical products, and slightly less for horizontal products, around about 25 years. And quite simply, that's because it's a heat exchanger with no moving mechanical parts. So it really is, once it's installed as part of the infrastructure, there's no reason to think anything's going to go wrong with it. And then finally, for those who have an eye on embodied carbon, wastewater heat recovery and certainly the Recoup suite of products have a very low embodied carbon, and we can look at that in a couple of slides as we go through towards the end there. Just a quick note for those that are coming in a bit later and those that are here now. Hopefully you can see the full screen. If you can't, just at the bottom left, there's 3 dots there. If you click fit to frame, that should expand the frame out completely, so you can see the whole presentation here. Okay, so we're just going to quick look at how wastewater heat recovery works, general overview. We have a full range of products in the portfolio, but the one that we're going to focus on here is the vertical pipe system, because that's most applicable for new build housing. So we'll have a look at that here with an animation. So the animation you're about to see is essentially showing a shower on the first floor, as you might expect to see in a new build house, with the wastewater heat recovery pipe located below that. It's gravity fed. So when you shower, normally with showering with a thermostatic mixer shower, what happens is the comfortable 38-40 degree shower temperature that most people will be showering under is made from incoming cold water at about 10 degrees, around about 50%, and around about 50% generated hot water at about 55-60 degrees. And the thermostatic mixer will automatically adjust that ratio of hot to cold to maintain that constant temperature, or the desired temperature, at a fixed flow rate. So the first thing to say is that wastewater heat recovery requires a thermostatic mixer shower to be SAP compliant, and that's because the mixer will adjust the ratio of hot to cold in the background. So when you're showering, around about 85 to 90% of the heat energy from the shower head normally goes down the drain and leaves the building. So showering potentially is a big energy loss, and there's a lot of heat energy locked up in that shower drain water that's leaving the building. So it's a big heat loss. So wastewater heat recovery quite simply focuses on that warm outgoing shower water. And we, as you can see here, we will put a heat exchanger on the outgoing shower waste so that the warm shower waste will drop through on one side of the heat exchanger, in this case the pipe, and then that vents off to the SVP as normal. So we're not harvesting the grey water, we're not saving the energy, it's literally heat exchange, and that heat is exchanged with the incoming cold water. As you can see, the cold water feed coming in here. So if that cold water feed's coming in at around about 10 or 12 degrees, the cold water is then preheated, so that will go around the outside of the heat exchanger and is preheated up to about 25 to 28 degrees. So immediately you can see we're getting a big free energy uplift from that outgoing wastewater. And that's the basic premise of wastewater heat recovery. It's a simple heat exchanger technology. But as you can see here, what we're, sorry, one moment. I'll move on just one slide. So there are, we're showing here System A, which is a SAP recognized installation method. There are three installation methods: System A, System B, and System C. And they're all quite simply to do with where you send this preheated water coming out of the wastewater heat recovery. So here we're looking at the most efficient setup, which is System A, where we're sending the preheat to the cold side of the shower mixer and also back to the hot water source, whatever that may be. We're completely technology agnostic. It can be a combi boiler, a cylinder, a smart cylinder, air source heat pump, heat interface unit. It really doesn't matter from our point of view. As long as the hot water source can accept a preheated cold feed, that's fine. And so what happens with System A, by sending preheated water to the cold side of the mixer, what will then happen is the shower mixer will adjust the ratio of hot to cold from that 50-50 standard to around about a 70-30 in favour of the free issue cold side. So immediately you're using less hot water per shower. And then also by sending the preheat back to the hot water source, so in this case a cylinder, but the cylinder now only has to work to heat from about 25 or 28 degrees up to 60, rather than heating from 10 degrees up to 60. So we're using less hot water per shower, and the hot water we are using is being produced more efficiently. So that's System A, and that's the setup that we would normally expect on a primary shower in a new build dwelling, for example. System B is a less efficient method of installation, but also requires less installation, and quite simply, we're sending the preheat just to the cold side of the shower mixer. So what this is doing is just adjusting that ratio of hot to cold in favour of less generated hot water and more free issue cold water or cold side water. This will reduce the amount of hot water required per shower by about 42%, 43% in this setup. So it really is still quite significant, although it is on the lower side of what can be achieved. And then for completeness, System C, as you may have guessed, is where we send the preheat just to the hot water source only. So this is not used so often in residential, but where you may see it, for instance, if you have a townhouse setup where you might have a second floor shower stacked above a first floor shower, the wastewater heat recovery will locate on the ground floor, and then it's probably easier and cheaper in terms of installation to just pipe through to the boiler or cylinder, which is in most cases probably going to be on the ground floor as well. So it's a solution that sits in between System A and B, but realistically in new build will probably reduce the amount of plumbing and pipe work that's required. So it's used in that respect. So just to qualify those installation methods, savings quickly. So as any heat exchanger will work, the slower the flow rate across the exchanger, generally the more efficiency you will get. So here we're showing two common shower flow rates. So this is a shower measured at 11 litre per minute flow rate, which is the old default shower flow rate. And then under new regs, it can be specified anywhere between 5 and 13 litres per minute. So quite commonly now in new build, 9 litres per minute is the default. So as you can see here, the heat recovery efficiency will increase as the shower flow rate drops. But that overall energy demand reduction that we mentioned, so for system A, would be around about 54-55% for an 11 litre per minute shower, and anywhere up to about 58% energy reduction for a 9 litre per minute shower, and that will increase as shower flow rates get lower. On system B, which is the other end of the overall efficiency scale, we're looking around about 40% hot water reduction for system B at 11 litres per minute, and around about 43% at 9 litres per minute. So again, very significant, even though this is the lesser efficient system. So just a quick note on that. System A would normally be installed for the primary shower. If you have a larger home or dwelling with more than one shower that needs wastewater heat recovery, the secondary systems will always be System B. System B is completely closed loop from the hot water side, and so that means that you're only feeding preheated water through the primary shower and not any secondary shower. So it doesn't dilute savings if only one shower is being used at the same time. We can kind of look at more of that on the design-in element. I'll just pause there for a moment, James, just to see if there are any questions or if there's anything from the floor just on that basic wastewater heat recovery.
Hi, yes, there's a couple of questions come through. One, I think you'll go on to later on in the discussion. However, Rich has just asked about the heat recovery. Did you mention 80%, which seems particularly high? I think maybe that was a misunderstanding.
No, yeah, I think it might be a misunderstanding. So of the warm water coming out the shower head, about 80 to 90% of the heat energy from that shower head. So if 40 degrees is coming out the shower head, the water that hits the drain is around about 34 to 36 degrees. So what we're saying is you only lose about 10 or 15% of the heat energy from the shower head before it hits the drain. So there's a lot of heat energy there. The products themselves are third-party tested and validated and obviously used by BRE and SAP. The heat recovery efficiency of the pipe systems are about 60, 65, up to 67%, depending on shower flow rate. That's all available on the PCDB, so we can send those across if anyone's interested at various flow rates. I will focus on that a little bit more on the different product types and the different efficiencies now. So that leads quite nicely into a quick look at the pipe hex. So this is the one we've focused on so far for new build housing. The reason it works so well for new build housing is it's the most efficient product that we have in the portfolio. It's generally the most best priced product because we sell it in very high volume through the merchants, and therefore it's the most cost effective in terms of SAP points versus installed cost. However, as you can see here, the negative, if you like, on the vertical pipe product is that it's gravity fed. And being a 2 meter vertical pipe system, it needs to install on the floor below the shower it connects to, which is why it works very well for standard new build housing. But for instance, we might need to look at other options for apartments or ground floor showers, which we'll look at in a moment. So the pipe is generally the go-to new build housing solution. As we said, efficiencies, in fact, the SAP listed efficiencies for this at 5 litres per minute is a bit higher. But our tested efficiencies, so third-party tested efficiencies across from 12.5 litres per minute down to 5.5 litres per minute, range from about 60 down to about 67, up to about 67% heat recovery efficiency of the unit itself. And then obviously that's of a percentage of heat energy that's going down the shower. So that's where that lower overall efficiency comes from, which we can sort of focus on in a moment. It's a very simple product to install. So we're showing here the vertical pipe system. As you can see, we have, sorry, I've lost my cursor, there we are. Normally what will happen is your warm shower waste will come in to what we call the turbo rotator. The turbo rotator is just a waste assembly that's used to direct the flow of the wastewater. So it will rotate and essentially spin. So it will then cling to the inside of the copper heat exchanger pipe and full in what's called thin film heat exchange. So we're maximising the surface contact with the inside of the exchanger and maximising the heat transfer ability. And so that grey water will drop through and then vents off to the SVP, as we've said. At the same time, you will draw your incoming cold water feed through the unit, round the outside, and then that's preheated. So as you can see here, what we supply with the pipe hex kit is all shown here. The only additional elements that are required for installation are a double check valve, 2 isolator valves, so an isolator valve top and bottom, and then 2 1/2-inch BSP connecting irons, one top, one bottom. So it really is a relatively simple, cheap and quick product to install at first fix. It also, as I said earlier, requires very little design changes to existing homes or takes up very little floor space in new build. So where we box in next to the SVP on the ground floor normally, your standard SVP boxing will be around about 220 by 220 mil normally. Well, wastewater heat recovery included will just add about 200 millimeters in one direction. So it really isn't taking up a great deal of floor space. And as you saw from the example here, certainly can be boxed in behind kitchen units or, you know, in the corner in a lounge or a hallway or something along those lines. So it really is quite a simple technology to design in. Just a quick cross section through the heat exchanger unit. So as I mentioned, when the warm waste flows through, it will cling to the inside of the heat exchanger pipe here. The cold water main will flow through between the copper exchanger and the PVC outer here. And then the eagle-eyed amongst you will see that there are actually striations or marks running around the middle of the heat exchanger here. All Recoup products use a double-walled heat exchanger system. So this is a mechanically pulled pipe through a pipe, and these striations run the entire length of the copper heat exchanger. What it does, it gives us a visible leak detection system, which is a belts and braces approach to water regulation compliance. It means in practice that with a visible leak detection system in place, the shower trap can remain upstream of the wastewater heat recovery underneath the shower where it belongs, rather than having to come downstream of the unit, which potentially causes issues in terms of installation height and accessibility and things. So all Recoup products use a double-walled exchanger. It means we directly comply with EN 1717 and UK water regulations, and the shower trap stays in place under the bath or shower where it belongs. For the house builders in the audience, just so that you know, we can dovetail into existing supply chains. We're the only product that's stocked and sold through all of the major national merchants and plumbing and heating distributors. Just a quick overview on installation operation. We've kind of touched on this really, but wastewater heat recovery is generally a first fix installation product, installed around about 1 to 2 hours of extra plumber's time. It really is that simple. Only basic plumbing materials and tools required, so off the shelf, isolator valves, etc. Standard tools, no specialist training, no MCS accreditation or certification required, and no commissioning other than the standard pressure testing of the hot water system. No planned maintenance required, as I said earlier, because there's no moving mechanical parts, no filters, no consumables, and importantly, no behavioural changes. So your end user simply won't know it's there in most cases. So as I said, the pipe is absolutely ideal, but the only negative is that it being gravity fed, it normally needs to install on the floor below the shower it connects to. So that generally rules out ground floor showers and apartments. So for those scenarios, we have a range of other products in the portfolio. And the next most cost-effective one, I think is probably the way to say it, is the Easy Fit, which is an underbath system. So this is a standalone wastewater heat recovery system, a horizontal system designed to locate in that unused void space below the bath. By their nature, horizontal systems aren't quite as efficient as vertical systems. So the Easy Fit is around about 2/3 the efficiency of the pipe, but sells out at around about the same cost. So it still has good cost efficiency. And certainly for apartments and ground floor showers, it really is a very cost-effective solution. So whilst it's designed to fit under a standard size bath, anywhere between about 1400 and 1800 ml bath, It can also fit under a suitably sized shower riser tray. So anything realistically probably from about 1400 and bigger. So it does cover a number of bases in terms of apartments and retrofit and ground floor. We do then have other products as well. So yeah, the EasyFit again works in the same basic principle. Warm shower waste running into the unit, runs off and vents off to the SVP as normal, and then cold water main being drawn through on the opposite side, counterflow heat exchange. In this case, we have a kind of a flat serpentine exchanger, so a flat coiled exchanger here, which runs the entire length of the unit, and then this will then come out preheated. The way this works is the warm shower waste will flow in and is allowed to flow across the base of the unit. The exchanger is about 2 millimeters above the base of the unit, so under normal flow rates, when shower waste is flowing through, that waste will mix and turbulate and run over and under the exchanger. So we're getting lots of mixing, lots of contact and lots of heat exchange. But once the shower's finished or the bath water's finished flowing through it and the waste flows through, any debris, hair, anything along those lines that the shower trap hasn't caught, because obviously the shower trap's in place doing the heavy lifting, but any hair that might go through would just flow through the unit. So it's designed completely differently to anything else on the market, and is designed to allow debris to flow through rather than focusing them onto a smaller, more focused area, as some other units do. So it really is a good solution for underbath and under shower systems. Although I said it isn't quite as efficient as the pipe system, the way that SAP calculates hot water and SAP scores for apartments, it does mean that the EasyFit, if installed, designed into perhaps a shower over bath or a master ensuite shower, can score almost similarly to the pipe in a residential house scenario. So they do score very similarly in terms of SAP points, and they are priced very similarly. So they are both very cost-effective options for either apartments or houses in that respect. And then finally, we're seeing a lot more low-profile shower trays being designed into apartments now. So we've now developed a new product, or in fact an upgrade system for the existing pipe, where we have what we're calling Pipe Hex Active, so the active upgrade system, which essentially is a pump system with rather than the standard turbo rotator, it has a buffered turbo rotator. And what this does, this allows the high efficiency of the vertical pipe system to be leveraged when you've got apartment showers or ground floor showers with a service void behind them. So this then allows the pipe to be used on the same floor as the shower it's attaching to, rather than the floor below. And it works quite simply by, let's have a look what we're on to next. It works quite simply by the warm shower waste running into the pump system. So this is a flow activated Saniflow pump. We've teamed up with Saniflow using essentially off the shelf pump system, great pedigree, great servicing, great warranty. So it's all very much known quantities. And what this will do, it will activate, and then it will very quickly pump up a volume of wastewater into the buffer cylinder, and then that will allow that to flow through the wastewater heat recovery as that cold water is coming in and then comes out preheated. So the pipe system itself is working in the same way, but what we're doing, we're pumping up and over periodically. The way the pump works is it's already a very low wattage pump, around about 250 watts. But the way the system's designed with the buffer tank at the top, it's designed so that the pump is only in use for about 1/3 of the time that the shower is operating. So it means overall we get a very, very low additional electrical requirement for the wastewater heat recovery system. So low, in fact, that in the SAP PCDB database listing, they haven't attributed any energy loss from the pump system. So it really is still a very high scoring SAP option, this one. So as you can kind of see, just for anyone who's interested in how it designs in, essentially, as I said, that warm waste will drop into the Saniflow unit, that will pump up and over into the buffer and then back down. This is designed so that we can have offer some good flexibility in terms of designing in. So you can see here we can be around about sort of 1 to 2 meters away from the pump, between the shower drain and the pump, and then around about 1 meter away from the wastewater heat recovery unit to the pump as well. So for apartments, for modular bathrooms, and also for retrofitting, it does give a lot of flexibility in terms of designing this in. One thing to be conscious of, obviously, is you do need a fall. This is gravity driven, so you need a fall from the shower into the pump, and then from there the pump will kick in and pump that up and over electrically. That's the pipe active, and then just for completeness, not really used in residential too often, but we do have a range of wastewater heat recovery incorporated into standard linear wet room drains. So these certainly can be used in residential. It's often seen in DDA, so where you've got maybe disabled or accessible bathrooms on ground floors, maybe in social housing, but certainly in non-residential for communal shower rooms, for sports centres, for leisure centres, etc. When you have high shower traffic, these things have an incredible ROI. So really worth considering if you're looking at non-residential projects or sports facilities and things. I'll just pause there. That's kind of as much as we'll look at on the products, but obviously we have lots of collateral. So if anybody's interested in more detail, we can send that across. Any questions, James?
Yes, I've had a few. I've sort of gone back on some of the questions, but I think you'll be able to explain in much more detail. So just starting the first one. So I had a few questions about Legionella. So I don't know if you want to sort of start from the beginning on that,
sure.
or whether you want to leave it to later on in the presentation.
Yeah, so Legionella is something that obviously when you're preheating potable cold water, it's always something that's going to come up. All of our products and all installation methods are all Legionella compliance risk assessed, all deemed lowest possible risk. So essentially, installing wastewater heat recovery as per installation instructions shouldn't add any additional Legionella risk to a domestic or non-residential shower scenario. The caveats there are the wastewater heat recovery unit itself, and this applies realistically to the pipe system, shouldn't be insulated. So if, for instance, it's being boxed in next to an SVP, often SVPs will be insulated more for acoustic than anything else. The wastewater heat recovery unit itself needs to be left open so it can cool down as quickly as possible. So obviously our only heat source is the warm shower waste that's coming through when the shower's in operation. As soon as the shower stops, that warm waste just drops straight through, and then the unit can cool down as quickly as possible. The other caveat is that the length of pipe from the wastewater heat recovery unit to the cold side of the shower mixer, so that system B pipe work in 15mm copper needs to be under 4.75 meters, and that's then deemed that it will not add any additional Legionella risk. So in practice, even if you're installing a wastewater heat recovery unit on the ground floor and you've got stacked showers on first and second floor and installing under system B, most of the time that 4.75 will cover. So for almost all design eventualities, 4.75 meters covers. But obviously if you are designing in, we can always advise on that. We do have full Legionella compliance guidance separately as well, which we could send out to anyone who's looking at that. From a domestic point of view, Legionella generally isn't looked at too heavily because there isn't really realistically the same guidelines that are in place for non-residential. But if you have further questions, we can look at that separately. In fact, I think we've got a knowledge-based article which deep dives into Legionella, which I can send across. Anything else, JB? Does that answer okay?
Yeah, perfect. I've got a couple more questions. Some might have been answered sort of since the questions come in, but I'll ask them anyway. So can the pipe hex be installed on the same floor as the shower, and does this require a pump to be installed? So I think that's covered. And the other one, can an easy fit be installed in a timber floor void?
Yeah, good question. Actually, I've seen it recently. Somebody posted on Twitter that they'd done that for their own retrofit upgrade. So whilst wastewater heat recovery is deemed as fit and forget, no planned maintenance required, it is still a device, and as a device it should still have reasonable access. Now, reasonable in inverted commas is kind of what the installer, specifier or end user, I guess, deems reasonable. So for the vertical pipe systems, Recoup deem reasonable access being behind plasterboard, for example, because realistically, once it's installed, once it's pressure tested, or the system's pressure tested, it will just work, and there shouldn't really be any issues. If there were any issues, it can be isolated. The isolation valve obviously would be accessible on the incoming cold. The plasterboard can then be removed and the unit swapped out. In practice, that really doesn't happen very, very often at all. All of our products are pressure tested before they leave the factory gate. There's realistically nothing to go wrong on the units. We're very, very, very low post-installation callbacks, so it really isn't an issue. With the Easy Fit, personally, we wouldn't normally recommend that the unit is installed under a shower that's then going to be tiled in, because whilst it is ultimately accessible, whether you would consider that reasonable access if it's in a floor void under a shower, that's kind of a question for, I guess, you as a specifier or an end user as to whether you feel that's accessible. We wouldn't normally recommend it. Again, I've seen similar systems installed under shower trays. It's not normally what we would recommend unless it's a riser tray and that unit is then accessible through the riser. Sorry, and by riser tray I mean a lifted tray, which normally has a pull-out panel that you could actually get to the wastewater heat recovery unit, replace if necessary. So that's normally where we see it, but ultimately reasonable access, it comes down to the specifier or the end user rather than us as a manufacturer, but that's where our advice goes. Is that okay?
Yeah, lovely. A few more questions have come in as well since we've been talking. So does the distance of the waste pipe to the wastewater heat recovery unit make a significant difference?
Generally, no. So the guidance is all based on the SAP guidance. So no. I mean, ultimately, yes, it would do with incredibly long runs. SAP guidance suggests that where possible, the wastewater heat recovery unit should be within 3 meters of the shower drain. In practice, if you have a shower on first floor and the wastewater heat recovery either just below the ceiling or the rotator within the ceiling void, the fall that you need from the shower to the wastewater heat recovery unit, that angle generally dictates that more than 3 meters isn't possible. The height in a ceiling floor void tends to dictate it's not possible. So in most scenarios, it's difficult to design with the wastewater heat recovery and the shower further than 3 meters. That also then falls into that 4.75 meter maximum length on the System B pipework. Generally, all that is designed in quite well. Obviously, if you were to go further than that, that's why that guidance is in place, because it could ultimately impact the heat recovery efficiency on incredibly long runs. But realistically, it's not designed in that way. So in most cases, the wastewater heat recovery unit is located almost directly below the shower, because that's where the SVP and the waste pipe work is, and the incoming cold water pipe work in most cases. So it could be, but it's not in practice.
Okay, thank you. Just a few more questions. What is the likely maintenance of the system? How likely is it to get blocked? And what is the predicted lifespan of the product?
I think I answered most of those. No planned maintenance, shouldn't be any issues once it's installed, and 40 to 60 years on the pipe, 25 years on the horizontal systems, because they haven't been in the market as long. That will no doubt increase. We offer a 5-year warranty on the underbath system and a 10-year warranty on the vertical pipe system.
Okay. Ashley's got a question. Anything above 25 degrees on the TMV cold feed could cause issues. Is there a specific TMV selection required?
It's a good point, and it's a bit of a grey area. Ian, our technical director, is in contact with the governing bodies on TMV, because whilst obviously the delta T differential is important, in practice it doesn't seem to have issue. Certainly, wastewater heat recovery being installed with volume house builders and developers for 10 plus years now with the likes of Barratt, Redrow, etc. That has never been an issue. So it seems to be more of there is some guidance that says about differential delta T's, but in practice it doesn't seem to have quite kept up with the way that the technology's gone. So we are working on that. It's probably out of scope for this presentation, but happy to discuss separately because we're quite happy to get more information on that as well. I'll move on, JB, because time's running through, if that's okay. So why is wastewater heat recovery important? Why is hot water important? Historically, energy use in the home, typically around about 2/3 of the energy use would be space heating, about 18 to 23% water heating, the rest of it on appliance, lighting, cooking, etc. But as houses are becoming more and more energy efficient, more airtight, that percentage of energy used for space heating is contracting quite significantly. And obviously, by contrast, assuming nothing changes in terms of occupiers' showering habits and water use, the amount of hot water energy requirements is getting bigger by comparison. So when we look at typical hot water usage profiles, around about 50% of generated hot water in homes, in houses, is for showering. That can be anything up to sort of 70 or 80% in apartments where more of the generated hot water is using for showering. So wastewater heat recovery really is warm waste going down the drain and wasted energy really is a big concern. So we said earlier, 85 to 90% of that heat energy from the shower head can be going down the drain and is simply lost from the building. It's like having an open window whenever you're showering, for example. You just wouldn't do it unless you can help it. Certainly not from an energy point of view. So as I said, with standard sort of average homes in the UK, sort of 15, 20 years old, the majority of energy goes towards space heating, with the next amount as hot water. So if 50% of that is showering and 85% is going down the drain, potentially around about 10% of a average UK home's energy can be going down the drain as wasted shower water. So it's something that's very important. It's something that's being picked up more and more in the regulation now as well, and the direction of travel, as we'll see. This pie chart looks at the breakdown of space heating and the hot water under the new regs on an average 3-bed home coming in for 2021, or as we are now coming into 2023. So as you can see, space heating requirements is potentially lower, but hot water by contrast is relatively more, even though the absolute kilowatts will probably be the same, but the percentage of hot water is bigger, and so the percentage of energy from that home for showering is more, and therefore the percentage of wasted energy is more without wastewater heat recovery attached. And this just gets bigger and bigger as you move towards, for instance, passive house, etc., where space heating can be probably 10 or 15% of the overall energy use. So yes, it really is a big concern. This is something that's being addressed more now in new regulations. Certainly the Future Home Standard, which is due to come in 2025, is treating hot water and hot water efficiency much better than previous regulation has done. Just a quick overview on the Future Home Standard. It is still out for consultation, so nothing is decided as yet, but the expectation is that new homes being built from 2025 will require at least a 75% less CO2 emissions for new homes than those built currently, on previous regs. And the expectation is that gas boilers will be banned or fossil fuel heating, in fact, will be banned for new homes built from 2025 onwards. The idea is that all new homes will be electrical based, so heating and hot water based on electrical or renewable. And the idea there is that any new home built from 2025 essentially will decarbonise, so become greener, as the electricity grid ultimately becomes greener and moves to 100% renewables as we move towards 2050. So the idea is that any new home built in England from 2025 onwards will not need to be retrofitted to ultimately become net zero. So that's the ethos behind it. However, it's a big step for UK house builders, and so what we have is the interim Part L 2021, which are the regulations which we're in transition now going live to. So Part L 2021 is seeking a 31% CO2 reduction. It also has a primary energy metric in there as well, so reduced primary energy. And what it's looking at doing that through is improved efficiency and other measures which we'll look at in a moment. The questions sometimes come up as to why don't we go to all electric now? If gas boilers are bad, fossil fuels bad, why don't we go now? The reality is we simply do not have capacity in the grid to electrify all houses and also electric vehicles, which is also moving towards electrification. And when you look here at the current demand for energy from housing, where about 85–90% is through gas boilers and fossil fuels, it really completely outstrips the potential for the grid as we increase demand. So this peak energy demand from UK housing really needs to come down dramatically so that we can move to an all-electric system in the UK, if you like. So the key changes in Part L going forwards are improved building fabric, improved thermal bridging, PV used as a base case, but also wastewater heat recovery can be seen to reduce the energy demand from hot water significantly. And when we look at how much hot water demand here is for homes currently, we can really see that if we can reduce that by anywhere 30, 40, 50% through wastewater heat recovery, it's going to be a big win. So that's where wastewater heat recovery really comes in. As I said, the Part L is due to transition, so we'll be live from June 2023. And for the first time, the reason probably why a lot of you are here is that wastewater heat recovery has been included in the notional dwelling for the new build regulations. So the notional dwelling is is BRE's most cost-effective recipe for achieving building regulation compliance. Without going through in too much detail, essentially the fabric has been uplifted fairly significantly. The air tightness is still fairly similar. Gas boilers will still be permitted, but low temperature heating is required. The expectation is that PV will perform around about 40% of ground floor area, and wastewater heat recovery will be included. Now, this, whilst it's the most cost-effective recipe, it's also a good future-proofing recipe, because if you think that homes being built now will ultimately need to ditch those gas boilers maybe in 2030, 2035 and move towards something like air source heat pumps, the fact that you're including PV, so you have electrical energy to power your air source heat pump for your heating and hot water needs, but also wastewater heat recovery to reduce the amount of hot water required and therefore smooth out the seasonal variations from air source heat pumps, allow for better production of hot water with air source heat pumps. It does make sense that this notional dwelling is the blueprint for new build homes going forwards. I'm conscious that we're running quite low on time here, so I'm going to whiz through this bit, but essentially why are developers looking at still using gas boilers under new regs rather than heat pumps? The reality is that gas boilers are a known technology. Heat pumps are relatively immature in the UK market, and whilst heat pumps do a very, very good job and there are great heat pumps out there and being developed, the reality is we don't have the capacity in the heat pump market or installation supply chain at the moment to install heat pumps into all new build. And as we said, we don't have the capacity in the grid currently to cope with it either. So there does need to be these stepping stone measures. So what we're seeing is the majority of certainly volume developers are still looking at gas boilers for their developments going forwards. Whilst it's a cost-effective solution, it does, oh sorry, I've missed a slide there. I thought I had something different in there. It does also help with infrastructure transition as well. So, you know, obviously big sites moving from gas to electric, it's not an overnight thing. So it's quite right that we have these stepping stone regulations. I've kind of lost myself a little bit here. So there's been some really good work. If anyone is specifying or developer looking at the Part L solution, there's been some really, really good work done by the Future Homes Hub looking at transitioning from Part L old Part L building fabric, so 100mm cavities, for example, and gas boilers, and looking at transitioning to new regs and on with better fabric and things. So if you haven't seen the work that the Future Homes Hub has done, they've produced a couple of guides for masonry and timber frame. I'd really suggest you look at them. I'll leave a link. This has been recorded, we'll put it onto YouTube. I'll send the link out to everybody and put a link for Future Homes Hub, because it really is some good work that they're doing there. I will kind of just hold that there if that's all right. Sorry, I'm just conscious that we're not going to get through the design part. Any questions there, JB, or can I just move on quickly? I will stay on afterwards for questions, by the way, for everybody.
Okay, just one very quick question. I've tried to sort of go back to many in the chat. One that's probably easy just to explain is how does it perform in hard water areas? Yeah,
no issues with hard water. Whilst obviously it's something that should be considered, we're really only taking the cold water to sort of 25, 30 degrees maximum. Seasonal temperature variations in the UK will quite easily hit 25 degrees in summer in a lot of places. So there's no reason to think there's any more problem with wastewater heat recovery installed than your plumbing system without wastewater heat recovery installed. In the main, we're on the cold side, we're not on the hot side. So even our feeding the hot water system, we're still on the cold side of that, not on the hot side of that. So there's no reason to think that cold water, hard water would be an issue. And in practice, and certainly with sort of 20, 23 years worth of installations here and in Europe, there's no issues with hard water. If you're looking at designing wastewater heat recovery, realistically it's very simple to design. In the main, for most houses, one wastewater heat recovery unit, the pipe installed as system A to the master ensuite shower or the primary shower is going to give you your biggest uplift. It really is that simple, and for probably 80-90% of house types, that really is the biggest uplift that we'll see. Obviously, if you have more than one shower in a home, ideally you want to cover all showers with wastewater heat recovery to maximise the impact and maximise the SAP gain. There are cost-effective ways of doing that. Certainly, if you have a very big house that has showers on different sides of the house, for example, you might need two or more wastewater heat recovery units. As I said earlier, normally it's going to be one installed as System A, anything else installed as System B, and that will cover you with kind of maximum coverage, maximum impact. But if you have the option to sort of design in your bathrooms so they're back to back, the reality is you can probably get sort of two showers, a shower over bath and an ensuite shower into one pipe, and so it reduces the amount of cost but maximizes that impact. So that's always the goal, and certainly we're here to guide you through it, to support you. We've got a great technical team here. We're happy to go over house builder or self-builder plans, that sort of thing. If you're looking at projects at early stage, just engage with us. We can give you quick advice on best options. It really doesn't take very long in most cases. Just to qualify the impact in SAP, because that's realistically what we're looking at here. We've got an example here, which is a standard 3-bedroom house type, first floor showers. In this case, we've got a master ensuite with a shower, and then a family bathroom with just a bath, in this case, just to keep it simple. And so what we're looking at here is, as I said, we're looking at the pipe installed as System A onto the master ensuite. If you do send floor plans to us, we can come back with a tabulated list of options. On something like this, it's very simple. There's not many options, but what we'll always come back with is specification notes, design and installation notes, and also for the SAP assessors or those who deal with SAP assessors, we'll pop in the PCDB number, so you can just pop that into your SAP software rather than looking through pages and pages of different products and trying to work out what should be installed. So we make that nice and easy for you. If you are installing into SAP, and again, this is just a very quick overview, but we can look into this in more detail with you separately. But the SAP software, it's been a bit of a rocky journey, I think would be fair to say, for SAP 10.2 introduction. It's working very well now for wastewater heat recovery, it appears. The only thing that we've seen in terms of problems is that when you're going through and putting in your wastewater heat recovery unit, adding in the PCDB number or choosing the product here, you then go through and add in whether there's any baths within the dwelling. And then from there, you have to connect the wastewater heat recovery unit to the shower, and this is the bit that people are sometimes missing. Because it's a dynamic system, depending on your screen size, sometimes this box will appear out of frame down here. You need to click onto this, it will open up another box, and this is where you then link your shower or showers to your wastewater heat recovery unit. So in this case, we would have specified our pipe as system A, and then now what we're going to do is write in ensuite shower, we'll connect it, and we'll also specify the shower flow rate. So I think in this case it's 11 litres per minute, and then that will output your SAP. So just to look at what it looks like in SAP and in terms of CO2 and primary energy, if we take that 3-bedroom as a mid-terrace, we've got the system A pipe to the ensuite, and we can see we're getting a big primary energy reduction here. So 10.7% energy reduction due to the use of that wastewater heat recovery pipe. So it really is very significant, but also quite nicely it ties into some of those numbers that we were showing in the pie charts earlier, that realistically we are seeing that level of energy reduction due to wastewater heat recovery on homes. As a CO2 reduction, it works out as 11.10%. I will caveat this is a SAP 10.1 that we work these on, so it might be slightly different now, but it's certainly in the same ballpark. For larger homes, potentially 7% energy reduction, because obviously bigger homes, hot water use versus space heating ratio is slightly different, but it really is very impactful, and I think that's the one to say. Now we can deliver much more granular calculation sheets for you. So if you're working on bigger projects, non-residential projects, retrofit projects, or quite simply you really want to delve into it in a bit more detail, we have all of this. We can either base it on SAP defaults, as this example is, which is based on that 3-bedroom there, or we can base it on project assumptions. If you're working with, I don't know, leisure centres with high hot water use example, we can tie that into the DSM models for you. So feel free to, as I say, engage with us on that. One thing I will draw your attention to here is just the overall CO2 reductions for this 3-bedroom home. So on a gas boiler, we would be expecting around about 164 kilograms of CO2 reduction per year. So that's your operational savings. Direct electric, that would be 270, and against an air source heat pump, about 131. I mentioned embodied carbon. Because of the way that we produce our product, and because of the high recyclability of the main materials, copper in our product, and PVC recyclability, we have a very low embodied carbon. So we worked with CIBSE in developing providing data to help develop their TM65 standard for embodied carbon. And I'll just whiz through this very quickly, but as you can see down here, the net result is the embodied carbon CO2 number for each pipe is 59.63 kilograms of CO2. So that's our embodied carbon required to produce a pipe. And then when we compare that back to those operational savings, you can see that is really, really small. So your operational savings per year versus the carbon required to produce the product is incredibly low. And then when you look at that on a full lifetime as sort of 40 to 60 years, or across the lifetime of a home, that really pales into insignificance. So if embodied carbon is something you're looking at, whole life cycle carbon, wastewater heat recovery really, really does hit the mark there as well. So it's worth considering that. And I think that's probably about it. I've just got a quick overview just for apartments here, but I think we've kind of covered most of this in that. If you're looking at apartments, realistically, the easy fit installed to a shower over bath, which is likely to be your primary shower, is the first one you'd look at, and then potentially you have the option for the pipe hex to any master en suites that might be low profile shower trays. And that's that there. And sorry, where are we time wise? Hopefully everyone's all right. I'll just whiz through a case study and then we will finish. So Recoup have been in the market for over 10, 11 years now. We've been lucky enough to be sole supplier to Barratt, who's the UK's biggest house builder, for 9 or 10 years now, and also supplied most of the sort of top 10, top 20 developers on various developments and regions across that time. So there's lots and lots of case studies and installation for standard house type to hit Part L, but the one to really focus on is the future. And Barratt have, you've probably seen in the press recently, Barratt have built their Z House, which is a net zero ready concept home designed around a standard 3-bedroom house type that they have. So what they've done, they've looked at around about 40 available, so cutting edge but available in the market now, energy efficiency, biodiversity and sustainability technologies, and they've loaded it into their standard 3-bed house type, completely reconfigured how they build these things, and they are using that as their exemplar, and they think that this essentially is their model now for new build homes going forwards from 2025 2030 onwards. Cost-effective homes that are net zero ready. Now, importantly with this one, as you can see here, the wastewater heat recovery is included and nicely low profile out the way there, so it's boxed in just behind the kitchen unit here. This particular one, as we showed earlier, is connected to both the ensuite shower, and also you might be able to see here it's taken the waste from the shower over bath, which is just located next door. So we're maximising the impact of the wastewater heat recovery. However, because this is an exemplar home, a pilot home, it's using air source heat pump for its hot water. It's also using a Kelder powered low flow shower around about 5.5 litres per minute. So exceptionally low flow shower, which means we're getting exceptionally good heat recovery efficiency, and then also a standard restricted flow on the shower over bath. So it just goes to show that wastewater heat recovery really can work with future homes and future technologies, and I will kind of leave that there, I think. In terms of resource, we've got lots and lots on the website, on YouTube. We're recording these videos, so you can always go back and watch them again. We do have this studio here with also products set up exhibition style. So if you want toolbox sessions, if you want branded materials, we can send them out to you. And just finally, just to say thanks very much for your attention, everybody, today. I'm sorry I've had to kind of rush through a little bit here. We'll pause for questions now. But just to say, I'll come back to everybody with a link to the presentation, but also as part of our sustainability drive, we'll also donate 25 trees for everybody that completes the CPD certificate link. So there's no pressure on feedback there, but as long as you just fill out the basics for your CPD certificate, we'll donate 25 trees and we'll alert you of that once it's done. So thanks very much, everybody. I will pause there and just see if there are any more questions. Have we still got many on, James? Looks like there's still a fair few left with us, so that's good.
Yeah, we've still got a good number on. I think we've answered most of the questions in the chat box. However, I'll sort of open the floor if anyone wants to come in and ask questions that we haven't covered.
Yeah, could I jump in there? Just quick question around hotels. Have you installed these products in many hotels, or is that something you wouldn't do?
Yes, yes, in fact, let me just whiz through. Preempted that one. One of the first hotels that this was installed in was the redevelopment of the Camden Town Hall Annex, which is just, if anyone's London based, just opposite the King's Cross Hotel and King's Cross Station. So it's the old Camden Town Hall building. It is now the London Standard Hotel. So this is, I guess you would mainly call it a hybrid new build retrofit, because they had to keep all of the existing facade and then built on 8 floors on top. So whilst they were using podded shower bathrooms here, they could only get pods into around about 150 of the bathrooms of the 270 rooms. So whilst it's a 270 room site, there were 150 wastewater heat showers with wastewater heat recovery used. So what we ultimately designed in, this was an Arup designed project, and we worked quite closely with them, supporting them on this. We looked at putting the back-to-back shower rooms, so each room with an ensuite shower, running back-to-back. So the wastewater heat recovery unit locates in the service riser, which obviously runs the entire length of across all floors. So it makes it very replicatable. And then what this is doing, we're taking the warm waste from both showers. We're installing a system B, so we're completely isolated from the hot water plant and the hot water pipe work. And all we're doing here is that cold water gets drawn through when one or the other shower is in operation, drawn through and then feeds to the cold side of the mixer. So system B is almost exclusively used in non-residential scenarios, especially if you have centralized hot water plant, because when you've got multiple wastewater heat recovery units, as we do here, you can't be drawing them and sending them back to the hot water plant, so that they're all completely isolated, just feed the cold side of the shower. So this is one of the earlier. This was, I think, completed and handed over in 2019. But we have any number now of hotel and student accommodation, which is very similar blueprint projects in design that we're supporting on. I mean, Arup have done quite a lot of work on this, so they recommend now that wastewater heat recovery is used for new hotels and major refurbishments. So this was part of the studies that they've done since, and certainly I can think of probably 8 or 10 different projects of similar with this.
It sounds very similar to what we're looking at the moment on, again, a very similar project in London. I've got a couple of questions, if you don't mind me just asking. Would you provide any sort of guarantees when it comes to the thermostat mixing valve? Obviously, we understand that you're not getting any problems with that sort of thing. From our point of view, from a technical point of view, there is an issue there.
Yeah,
so would there be any sort of guarantee or not?
Yeah, what we would need to do is work with the TMV manufacturer that's specified, because obviously it's not for us to guarantee anything on somebody else's technology, but we could certainly work with them to understand whether there is any potential issue. Obviously, within a hotel or a student project, you're likely to mitigate some of that seasonal cold water temperature from outside, but you will have a more ambient cold water temperature from it being stored inside. So it's certainly something that we can look at with you and with the TMV manufacturer or selected manufacturers. It's not my area of expertise, although I've kind of got involved in a couple of elements of it. It really is, our technical director Ian has done a lot of work on it, and he sits on a couple of steering groups with BRE, for example. So it's a much bigger conversation that we can have, or a more specific conversation we can have with you, for sure.
Yeah. Okay. Brilliant. I'll put all of this into an email if you don't mind, and send it over to you. But my only another question was around Legionella. The same again, really. In a hotel, obviously, you could have children, you could have elderly people showering, so the Legionella risk is a little bit
obviously
more
Legionella
of a concern,
needs to be signed off. Absolutely. So
again,
so
is there like a certificate that you guys have got to say like the risk, as long as it's under 4.75 meters, which I think was the figure that you said?
We have full Legionella guidance and a Legionella report from Legionella Control, who are risk assessors for Legionella. So we have all that paperwork behind this. Whilst obviously there are some more nuanced elements, the main two parts are that this unit isn't in an area of high ambient heat. So it's allowed to cool down as quickly as possible, and doesn't have a heat source next to it. So, if you've got perhaps heating and cooling ducting going through, that might need to be considered to be suitably far away from the unit if it's in a riser. Then realistically, it's just this length of pipework from here to the mixer, and it's the linear length as well. So that sort of 15 mil copper at 4.75 meters, and with the amount of volume of water within the wastewater heat recovery pipe, is under a litre. So it really is very, very small. I mean, we get these questions a lot, and we field them, and we have the risk assessment to go with it. It's also you need to look at what other hot water plant you've got going on there as well. So,
no, that's absolutely fair enough. Would you be happy to release that document?
It's on our website, but I can send it to you directly. Yeah, it's not. Absolutely.
I'll put that into my email as well. Then, my last question was around Part L for a hotel. Then, how would you sort of include this in the calculation for Part L? I don't believe it's as straightforward as it is for SAP calculation, if I'm correct.
It can be straightforward if you're using SBEM. So SBEM, in the same way that SAP is, you have those drop downs. However, for most big projects, DSM is the route through. So we have been lobbying IES and the providers to try and include wastewater heat recovery in their DSM software. They haven't included it particularly well as yet. So in IESVE on Apache, for example, which is their HVAC upgrade for IES, wastewater heat recovery is included there. So it can be incorporated much easier there. If you were just looking at standard DSM, essentially this calculation, I don't know if I've got one here, actually I might have one on this side. The calculation sheet that no, I haven't got it here. Yeah, the calculation sheet has all of the information, so we can tailor that to your project. We can either take your hot water volumes for the project that you're using in DSM, and maybe if you're breaking that down into shower basins, etc., we can use all of that info and plug that into our calculator and work with you and work on different assumptions, number of rooms, etc., and get that into complete granularity. You can then either take the kilowatts that are saved through wastewater heat recovery use and input that under DSM, or you can look at artificially either inflating the efficiency of the hot water plant so it does the same job, or
that's what we've done so far.
Yeah, or you can inflate the incoming cold water temperature so it does the same job. But all of those are legitimate workarounds that have been used on other projects. And again, we can supply that calculation tool and other elements just so that you've got all of that backed up. I mean, essentially with IES and building regs, as long as you as the specifier are happy that you've signed off everything, you know, in terms of got compliance for the numbers that you're putting in, then they will accept that. And part of that is us working through the calculations with you, so you have that granularity and visibility, and it ties in with your models. So yeah, absolutely, we can do that, and we do that with most of these other projects, because unfortunately it's not as straightforward as we'd like it to be at the moment.
Okay, that sounds great. And sorry, I'm asking loads of questions, but do you have a representative in the southwest? We're in Bristol, and it probably with this project, it'd probably be nice to catch up with somebody, run through the project entirely, and just face to face go through it. Is that possible?
It's possible. We like to do as much as we can remotely, just because of the carbon and the travel. But as I said, we do have this studio here, so we can go through, and you know, I can point the cameras at the exhibition that we've got here and things like that, so we can go through all of that. More than happy to do that with you. However, JB is your direction next week, I think, and the week after, so we might be able to tie it in with an existing.
Okay, I'll put that in my email as well. And it would is there an opportunity to maybe come to you guys then and see what? Yeah,
absolutely. If you want to. I mean, in all honesty, I would hope you shouldn't have to, but if you do want to come and get eyes on, you can do.
It's always nice to just see it physically before we start specifying it on. It sounds like a really good technology, so we'll be looking to specify it on most of our projects. So where is it that you guys are based?
We're in Norfolk, so it's always nice to come to Norfolk in spring.
Yes. Okay. All right. We'll try and tie that in. All right. I'll pop all this into an email. Shall I email to you and James? Is that right?
That would be great. Yeah, and I'll be following up with you anyway, so you'll have my email address.
All right. Cheers.
Brilliant. Thank you.
That was it from me.
Marvelous. Thank you. Anything else? It's good to see everybody's still on.
Everyone's still on, but nothing else popped into the meeting chat. So I don't know if anyone else wants to raise a question.
Okay, excellent. Well, look, all that there is then is for me to say thank you very much for everybody for your attention. Sorry, we've run over a fair bit actually, but thanks very much. We'll follow up with you with an email. If you do have any questions, any projects, etc., the links will all be there, as well as a link to the recording on this presentation as well, and some of the others that we've done. So thanks very much, everybody, and hopefully speak to you soon. Thank you. Bye-bye.